And I want to take a look at this formula for our confidence interval for a t distribution and compare it to the one for the z distribution. And specifically, I want to look at this z star and this t star. So remember when we were doing the z as in zebra, I gave you these confidence levels and the critical value z star that goes with it. Okay, so you could just always put those in every time you had a 95% confidence level, you would put in 1.96 for z star. You'll notice that when we switch to a T as in tiger interval, that I didn't give you a table like that. Okay, and that's because the value of T star is going to depend on the sample size. And more specifically, what you need is the degrees of freedom. So the degrees of freedom is always your sample size n minus 1. If I had a sample size of 50, my degrees of freedom would be 49. If my sample size was 75, my degrees of freedom would be 74. Okay, and so what we used to do was look all these values up in a table. Okay, so it was a table like this, and your degrees of freedom are listed along the edge. And this is a really nice table because it actually tells you what confidence interval you're looking at here. And these are the values for your hypothesis test. And so you would get the value you need, your T star, from within this table by finding the appropriate degrees of freedom and lining up with the confidence level that you're looking for. Fortunately, we don't have to do that. We have technology that will figure that out for us, and we don't have to go through excruciating detail in through a table like this. Okay, so with that in mind, now that we know a little bit more about T star and T distributions, let's do another confidence interval here. So good weather, good tips. Does the expectation of good weather lead to more generous behavior? Psychologists studied the size of the tip in a restaurant when a message indicating that the next day's weather would be good was written on the bill. The tips from 20 patrons measured in % of total bill are given in the spreadsheet. This is one of 3 sets of measurements made. So they actually were testing a couple different things. They looked at testing a message that said the next day's weather would be not so good, or there was no message at all. What we're going to do is look at just the data from the tips on the receipt that said that the weather tomorrow would be good. So we're going to estimate the mean tip for comparison with tips under other conditions by constructing a 95% confidence interval. So since it says confidence interval, we know we're going to do panic. Just put my letters down here. We're doing a 95% CI for the mean tip percentage. So it does tell us that these are measured in percentage. Okay, yeah, percent of the total bill. And then for A, we have simple random sample, normal large, and then sigma here. Okay. All right, so simple random sample. So it's not stated anywhere in here, but this is actually part of a larger problem. And in the larger focus of the problem, we did find out that the patrons were randomly assigned to receive one of these 3 messages. So I'm actually okay if you want to put a little star and put not stated. That's totally fine. I know from reading the larger problem, I just didn't want to give you paragraphs to read for not much benefit. So not stated is totally fine to put there. And there are ways of addressing that in statistics, but we're not going to worry about that in this class. That would be for another class. Normal and large. So we have n equals 20 and a sample size of 20, which certainly is not large enough. So we're going to need to make a normal probability plot since it does not state on here that we can assume the original population was normally distributed. And then there is no sigma here, so no population standard deviation. So that means we also need to go find S. So we'll do that when we go look at the spreadsheet with the data on it. So since there's no standard deviation from the population, and we're going to have to use the sample standard deviation, that means this is a T as in tiger, so 1 mean T interval. And then we're ready to construct our interval. So let's go to the spreadsheet and look at our data. All right, so here's our data. Let's start by checking to make sure that we have a normal enough looking distribution. So to do that, I'm going to click on the Data tab, and I'll click on Data Analysis. And then everything we've done in this class, we've used the regression choice off of this data analysis tool. Okay, and so my Y range, you always highlight your Y range first, which should be your second column, and then your X range, which should be this first one. That X range is usually the boring generic data. It's often an identifier for the people in your study, or it's just a simple count of 1 through whatever number your sample runs through. We'll click this button here for normal probability plot, and I'll say OK. And here's my normal probability plot. I would say that looks pretty straight. So I'm going to circle this word normal on my paper. And I'm going to pull a little star here and say NPP straight enough. And then I still need my X bar, so my sample mean. Remember the command for that is equals the average. And I'll highlight my data for the tips. That gives me my average, and then my standard deviation is equals STDEV. And I will highlight that tip data again. So I have X bar is equal to 22.2. And I have S is equal to 1.96. So that should be everything I need to go to the confidence interval calculator spreadsheet. Okay, so here we are. Notice that I'm down on the tabs down here that this is the T confidence interval from chapter 20. So just always make sure you're in the right tab. We're doing a 95% confidence level, so 0.95. My X bar was 22.2. S was 1.96. Okay, and let's see, my sample size was 20. Okay, so what does that make our degrees of freedom? Our degrees of freedom is sample size minus 1, so DF is going to be 19. And here are my two values for my confidence interval. So I have 21.28 to 23.12. All right, and then I think we're ready to write our conclusion. Okay. So our conclusion here is going to be we are 95% confident. The true mean tip percentage is between 21.28% and 23.12%. So there's our conclusion. A couple things to notice here. So I did circle the word normal and I put a star, put MPP is straight enough. You want to make sure that if you're using the normal probability plot that you do indicate that under your assumptions and conditions.